Welcome to the New Horizons Physics Podcast. A podcast where we will expose and debate the basics of various physics phenomena and current scientific discoveries. Today we will be talking about
Welcome to the Atomic Bomb, a short episode explaining the functionality of nuclear weapons and the principles of physics they use. In order to understand the design and how nuclear bombs work, we have to explain a few basic things about the atom. First of all, the atom is composed of three subatomic particles and has a nucleus that is the center of it. Here we see the protons and neutrons, which together compose the nucleus of the atom. The protons are positively charged, while the neutrons have no charge. The sphere you see spinning around the nucleus is the electron, which is negatively charged. The number of each particle an atom has is very important, because what differentiates elements and isotopes from each other is their atomic composition. Isotopes are just variations within the same element. Isotopes differ from each other by the number of neutrons they have. On the other hand, if the number of protons in an atom is changed, then the element changes completely. Coulomb's laws state that like charges repel each other, and unlike charges attract. The nucleus of an atom has many protons, and thus they tend to repel. To counteract this action and keep the nucleus together, there is a force present in the atom, which is called the strong force. The energy associated with this force is the binding energy. When the binding energy is strong enough to hold the atom together forever, the atom is stable. When it is not strong enough, the atom is unstable and eventually it will emit part of itself. This emission is what we call radiation, and the process of emitting particles is called radioactive decay. There are many types of radioactive decays, but the most important one is the spontaneous fission. A nucleus splits into two pieces, ejecting neutrons which become either neutron rays or gamma rays. The gamma rays are a form of electromagnetic energy and are the rays the sun emits.
Now, let's take a look to the fission bomb design. Think of it as a pool game. Each ball is a subcritical mass, which is a material that does not support fission. The cue ball is the neutron, and the group of balls are the critical mass, which is the minimum mass of fissionable material. When the cue ball hits a group of balls together, creates a bigger impact than, say, the cue ball hits just one ball. The neutron generator consists on having polonium, a radioactive element, create alpha particles that will collide with beryllium-9 and produce beryllium-8 and free neutrons. When the bomb is detonated, the neutron generator starts and creates neutrons, which collide with the critical mass. This reaction is contained in a tamper made of uranium-238 that contains the fissioning materials from exploding too early and bounces back the neutrons so they continue to fission material. Little Boy was the code name of the atomic bomb dropped on Hiroshima on August 6, 1945. The weapon was developed by the Manhattan Project during World War II. It derived its explosive power from the nuclear fission of uranium 235. The Hiroshima bombing was the second artificial nuclear explosion in history and the first uranium based detonation. Approximately 600 milligrams of matter in the bomb was converted into active energy of heat and radiation. The bomb consists on a bullet of uranium-235 dropped down a barrel to a sphere of U-235 protected by a tamper. Fatman is the code name for the atomic bomb that was detonated over Nagasaki, Japan, by the United States on August 9, 1945. It was the second of the only two nuclear weapons to be used in warfare to date. An estimated of 39,000 people were killed outright by the bombing at Nagasaki. The bomb consists on surrounding the tamper with explosives. These explosives explode, sending a shockwave to the core, which will detonate the bomb. Now, let's check out the fusion bomb design. The fusion bomb, also called thermonuclear bomb, instead of separating the nuclei, merged them, creating a bigger explosion than the fission bomb. The bomb merges deuterium and tritium, which produces helium and energy. To understand this bomb design, imagine that within the bomb you have an implosion fission bomb and a cylinder casing of uranium-238 or tamper. Within the tamper is the lithium deuteride, which is the fuel, and a hollow rod of plutonium-239 in the center of the cylinder. This is what happens when detonated. The fission bomb implodes, giving off X-rays that heat the interior of the bomb and the tamper. The heat causes the tamper to expand and burn away, exerting pressure inward against the lithium deuterate. The compression shock waves initiate fission in the plutonium rod, expelling radiation, heat, and neutrons. The combination of high temperature and pressure are sufficient for tritium deuterium and deuterium deuterium fusion reactions to occur, producing more heat, radiation, and neutrons. Finally, the bomb explodes.
Good evening. I'm Victor Santana, and I'm a doctor in the Nuclear Operations Centers of the NH laboratories. I'm going to talk about the health risk of the nuclear bombs. The health risks of the nuclear bombs are going to be caused by the idea that the closest you are to the hypocenter, which is the center which the explosion is going to be maintained at, is that the closer you are to the hypocenter, the bigger the damage will be. And that damage will be caused by four things. The first one that we're going to talk about is heat. The second one, pressure. And the third one, radiation. And the fourth one, radioactive fallout. Those four things in conjunction are what cause the main health inflictions in the human body to everyone that is affected by a nuclear bomb. The heat produced in the hypocenter is of 300 million Celsius. It is enough to vaporize everything or everyone that is around it. And basically, it's that if you're not vaporized by that kind of temperature, which is improbable, then you're going to get caught by fires that are going to be spawned by the pressure inflicted by the explosion. And so that's the first two causes of the damage, heat. And if you're not killed by the heat, which is improbable again, then you're going to be affected by the pressure that is going to create the fires that will spawn due to the explosion. Later on, radiation fallout. The The radiation after the explosion is going to spread out by the wind. It would also get into water supplies, and basically everyone will inhale it, or if not, ingest them, and will create several symptoms, if not just kill you directly, that will get you through the process of damaging your health immensely until the point that you die. The symptoms are basically nausea, vomiting, diarrhea, cataracts, hair loss, and loss of blood cells, which are gonna bring up more symptoms, which are the leukemia, cancer, and birth defects. So basically, the nuclear bomb doesn't only affect the ones that are present during the explosion, but the next generation that are gonna be born by the survivors. Because if the survivors were affected by radiation, those particles are going to rest inside of them and continue to affect them and continue to affect their breeds, their kids. So the next generation is going to be affected as well by the nuclear bomb. The spreading of radiation as well is going to could create a theory that many scientists refer to as the nuclear winter. The nuclear winter is basically a scenario where the clouds are contaminated by the spreading of the radiation and are going to create several attacks on the area that they are around. Those attacks are going to spread out basically through acid rains and through particles being exposed by the clouds as well. That are going to affect everyone that is living in it and the ones that are around it by a very big perimeter. So if a nuclear winter gets to happen, no one can be present to the point which we can say to the point which you can see the clouds that are contaminated, because the perimeter that it's going to be created or that it's going to be needed to isolate, it's going to be that big up to the point where people are not even in touch or close to being touched to the radiation. So those are the basic health risks, and they're added with an immense list of other damages created by nuclear bombs. And there are still survivors that are being studied because of the repercussions created by the bombs in Hiroshima and Nagasaki. And that's why we're preventing